Good day, viewers. In this virtual class, we're going to look at the derivative of cosec inverse of cosec. How do we find the derivative? That is inverse trigonometry of cosec. That will be our discussions. First, let's go into operation. Here, if we have y is equal to cosec inverse of s over a, first and foremost, here we establish the fact that this expression can also be written as s over a divided by cosec. Okay, we know from indices we have d raised to power 1 is equal to 1 over d. So that's what we've just done here. We're saying that this divide by this. Okay, the next step is for us to multiply both sides by cosec. So if we multiply this expression by cosec, this becomes cosec y is equal to x over a over cosec times cosec. This will be off, and this expression become, this function become cosec y is equal to x over a. Okay, this is one fact that we must hold with high esteem. Okay, that's cosec. Then the next step is that we also establish the fact that we look at the expression that we connect cosec. So cosec is 1 over sine. So this expression cosec y is the same thing as 1 over sine y. Inverse sine inverse of y is equal to x over a. Here we want to make y as its own expression, sine y. So here this become, if we invert now, the new denominator become numerator and numerator become denominator on both sides. So here we can say this is sine y is equal to a over x. We have inverted it. So this is expression for sine y. Then let's name this as equation 2. Then from equation 1, let's multiply both sides by a. Multiply both sides of equation 1 by a. This become a cosec y is equal to, if you multiply it by y, by a, this will just become x. Let's take this as our equation 3. Let's write it. X is equal to a cosec y. Okay, then we will use this fact to establish our relationship here. If this angle is y, then sine is opposite over hypotenuse. Opposite, which is a, and our hypotenuse is x. So there is need for us to find an expression for this by using Pythagoras theorem. And if we do that, BC, this line BC is the square root of the hypotenuse minus that of the opposite, which is a square. So that is BC. Okay, having obtained that, the next step is to differentiate equation 3. If we're going to differentiate equation 3, we will also establish the fact that this expression is x is the same thing as a over sine y. And for us to differentiate this expression, we're going to use the quotients rule, which is v du minus u dv all over what? V squared. So our u, this is u, this is v. Our u here is 1, this is 1. So this a is a constant here. So you see v du. We differentiate 1 is 0, use it to multiply this will give us 0. This will be 0 minus. If we differentiate sine, it's going to give us cos times, okay, u times 1. So times 1, that will just give us cos y, divide sine y, this sine y square. Okay, so the derivative of that will become minus cos y dot minus cos y over sine y times 1 over what? 1 over sine y. Okay, so that is if we differentiate this expression, our answer, the x over the y becomes minus a cot y, even the same thing as cosec y. Okay, that will be our expression. And we've already seen that cosec y here is x over a. So we'll put it here. We'll do what? We'll put it here. We'll see the y, the x, this is the x over the y is equals to minus a times the value of the ratio of cosec here is x over a times cot. Cot here is the inverse of tan. Let us now find tan here. Twa is what? Opposite over what? Over adjacent. This time is not going to be opposite, it's going to be adjacent over opposite, because the inverse, adjacent over what? Over opposite. So our adjacent is the square root of s square minus a square divide is adjacent over opposite, divide by a. Okay, so what we have here, this go with this, so that here we're having a minus, negative sign, so negative x over negative x root. Please, let's move this part to the other side. Okay, now if we find the derivative of the x over the y there, this become minus a cot y cosec y. Here we know that the x over the y is equal to cosec minus a. Cosec y is x over a. We put it here times x over a. What is cot? The cot here obtained here is the inverse of tan. 1 divided by tan. So if tan is opposite over adjacent, then cot will be adjacent over opposite. Adjacent over what? Opposite. Which is times root s square minus a square divided by a. Here a will go with a, and then we'll have the x over the y is equals to minus x over a, the square root of s square minus a square. So, but here we are looking for the y dx. that is inverse. So this become the y ds become minus a over the square root of x, the square root of s square root of x minus a square. So this is the derivative of arc cosec. Okay, if you are looking for the inverse, the trigonometric inverse of cosec, the formula is minus a divide x or the square root of s square minus a square. Okay, that is the simple derivations. Please, all you help me subscribe to my YouTube channel by hitting the link, and also hit the notification button, so that when this comes up, you will be able to have access to this wonderful piece of information. Have a nice time. See you in my next virtual class.